G'day, welcome to another Vector Basics video. This video will be covering projections, what they are, and how we solve them. So, if we had a standard vector v, and we had a second vector u, to find the projection of u onto v, we're looking for what is basically the shadow that u is casting over v, if we were to have a light pointing down above both vectors. Now, in this example, the projection of u onto v would be a scalar multiple of the vector v and would be of a smaller magnitude. But if u was a greater magnitude than v, then the projection would be greater than the vector v as well. So, the way we work it out is we know it is a scalar multiple of v, and that scalar multiple is the dot product of v dot u divided by the magnitude of v squared. Now this is a scalar and this is a scalar, so we're all good. Now if we had the vector v running along our x-axis in 2 dimensions, we call it 6, 0. And we had the vector u, we'll call that 4 and 3. Then the projection of u onto v is, so this dot product is 6 times 4 plus 0 times 3, which is 24, divided by the magnitude of v squared, which we know it's just 6 squared, times v, which is 2/3 times v, which we're applying to each of the components of v. So 2/3 of 6 is 4. And 2/3 of 0 is still 0. So there's our answer for the projection of u onto v. Now if we were also trying to find this angle theta by using Pythagoras theorem, we wouldn't be able to because the adjacent side is of a greater magnitude than the hypotenuse of our right triangle. So now that we have the projection of u onto v, we can apply Pythagoras. So cosine is adjacent over hypotenuse, so cosine of theta equals adjacent over hypotenuse, which is the magnitude of the projection u onto v, which we know is 4, divided by the magnitude of u, which the magnitude of u is 4 squared plus 3 squared, all square rooted, which is 16 plus 9 is root 25, which is 5. So we have cosine theta is 4 on 5. To find theta, we take the inverse cosine, which is approximately 37 degrees. So that is the angle between the vectors u and v. And we were able to work that out by taking the projection of u onto v. And I hope that this video has cleared up any doubts about projections. If you have any questions or comments, please leave them below. And I will see you in the next video.